All right, so any homework question? You need me help? Let's start with that question. Any question you want me to go over? So let's start with those questions. If you guys still have question, ask now.
2C.
2C. Okay, what does 2C says?
Give me a second. F of x equals, in a parentheses, 4 square root of x minus 5 squared, and then all of that over x square root of x.
Yeah. Okay, so this one is something that we did several times. Now, so go back, change your notes. That notes of things to avoid. Things to avoid quotient rule is you have polynomial. Polynomial only apply to x squared, x 1, like this, like polynomial, like 3x squared plus 2x plus 1, something like that, over a monomial. Then you can split them all up and take a derivative, because you can use a power rule much easier rather than use a quotient rule. Because right now you don't know how to take a derivative of 4 root x minus 5 to the square right now. Now, even later you do, is almost don't prefer. So what I will do is I will not do calculus first. I will do 4 root x minus 5 times 4 root
X. I think your pencil died.
4 root x minus 5 over x root x. Now I will change this square root x to x to the 1/2. So, and then I will do 4 root x times 4 root x is equal to 16x minus 20 root x minus 20 root x, and then plus 25 over x to the first to x to the 1/2. So that's going to be 16x minus 40, x to the 1/2 plus 25 over x to the 3 over 2.
Alright, I see where I messed up.
And then that's going to be 16x over x to the 3 over 2
I see where I messed up.
minus 40x to the 1/2 over x to the 3 over 2 plus 25 over x to the 3 over 2. I need to make sure I can simplify this, or 16x, I'll just do top minus bottom, it's going to be negative half minus 40x to the negative 1 plus 25x to the negative 3 over 2. Why? Why did I move to the top? Because I can take a derivative of that. So the whole thing I did not do any calculus at all. Now I show step by step. Normally I won't show this much step. Now I take a derivative using power rule. So it'll be negative 8x to the negative 3 over 2, because I take a negative 1/2 in the front. And this one's going to be positive 40x to the negative 2. And this one is going to be minus, I think, 75 over 2 x to the negative 5 over 2. Is that okay?
Yeah.
And that was my answers. Now I can take a second derivative. If I wanted to, I can take second derivative. But the problem is people get down to here, they thought that's already derivative. No, you didn't do anything derivative. You just do anything algebra. And if you have polynomial over monomial, that's the time that you should split. Same thing as this one, right? Same thing as 3x squared minus 4x minus 1 over 4. Same thing, you're going to do splitting, because now I know that this one is much easier to take a derivative. It only takes 10 seconds to do if you just do properly. So it'd be 3 over 2x. So this is f of x, and f prime of x, that's equal to 3 over 2x minus, in this case, x cancel out. This one's 4x over 4, so it's 1x, so it's minus 1 and minus 0. And that's it. So 3 over 2x minus 1. It doesn't not spend a lot of time to take a derivative of a function. If the bottom is monomial, it can split them. However, some people on a group chat yesterday, they say this. They say, well, Mr. Ye says bottom's monomial. But I think what my fault is I didn't say polynomial is not going to represent sine function. So I should have stressed So that's why you need to go back to change your notes. Is a polynomial over monomial. In this case, it's trig over monomial. They are slightly different. So I will do product rule here just because, no, I will do quotient rule just because this is this is much easier to do quotient rule. Low D high minus high D low over low low. Now don't forget low low. Like William just told me, he says, Mr. Yeah, I forgot low low. Yeah, something that people usually forget on test is a low low. Now I would get to here. Now some people says, a bit says, hey, Mr. Ye says don't use quotient rule, so use product rule, which is fine because you're gonna get same answer, but you're gonna realize it's a little bit harder. Because if I take a derivative of this, it's gonna be cosine of x times x to the -2 plus what? Plus sine of x times -2 x to the -3. And you're gonna be like, is that the same answer? Yeah, that's the same answer. If you pay attention, they are the same answer. Plus sine of x -2 over x to the cube. So now how do I get the same answer? If I multiply by x to the square over x squared, if you have multiply x over x, guess what? You're gonna get x to the 4th, x squared cosine of x, minus 2x sine of x, which is same as this. If you just combine fraction. So it's a lot more work. So I sometimes, like if you have trig over monomial, yeah, that's a case that I will use quotient rule because I don't want to use product rule. Even though it can be done, I want to figure out what is the easiest way. So go back to your note, says if I have polynomial over monomial, that's the time you split. Is that okay? Sorry about that misconfusion. I don't even know that's a word. Does that make sense? Now, I think that question Gabby did on the board, the one with sine of x times what? Sine of x plus cosine of x, is that right? Now for me, like if I take a derivative of this, I will use product rule. And like Andrew, he didn't write down the x. Please write x down because x is an argument. You had to plug in later. You cannot just say this. If you go out there, just don't tell me you're from Mr. Ye because you don't have an argument on a trig function. That's not good. That's not good. Usually they have argument, right? So if I were to take a derivative of this using product rule, then that's going to be cosine of x. See how long it take me to do homework. It's not long. It's not hard. You just have to recognize what you're doing. Pay attention in class. Cosine of x, sine of x plus cosine of x. And then this one's going to be cosine of x, right? Times, hold on a second. I did something wrong. Cosine of x, sine of x, and this one is wrong. Sorry. This one's going to be sine of x times cosine of x minus sine of x. And this is a derivative. I want to find the equation tangent line. I just plug in pi over 4. In this case, I don't need to simplify. I don't need to distribute. A lot of you guys distribute wrong. I saw some of you guys yesterday distribute wrong. Just plug in. And you're going to see a lot of things happen. Right? You're going to see a lot of things happen. You're going to see this is actually equal to 0. Why? Because square root 2 over 2 minus square root 2, that's 0. 0 times anything is 0. So the whole thing is 0. I don't even have to do any work. And then here it's going to be square root 2 over 2 times square root 2 over 2 plus square root 2 over 2. Then square root 2 over 2 times 2 square root 2 over 2. This cancel. Then it's going to be square root 2 times square root 2 is 2 over 2. That's equal to 1. Beautiful answers. And that doesn't take long. The problem is you guys start simplify things and simplify it wrong. You don't need to oversimplify if your goal is finding the slope. Because what's the point of simplifying your goal is slope? Now, if the goal is finding derivative, yes, I understand. Do you see the goal is different? Like, you don't want to oversimplify a thing. When you take a derivative, you want to find out slope at x equal to 1, plugging 1 right after it. Don't oversimplify. If you oversimplify, I'm not, like, the question is not asking to find most simplified form of derivative. Does that make sense? Okay, any other question? I want to try to do one the horizontal tangent one. So go to the last questions. What's a horizontal tangent? Can you give me one? Yes.
Can you do 3D?
What is it?
F of x is equal to x minus 4 over x squared minus 7.
Like this? That's it?
Square. Oh, x squared.
X squared is on the bottom. Okay, f prime of x is what? Low d high minus high d low over low low. It's actually not that bad. Some people think it's bad, but it's not. 2x times x is equal to what? 2x squared, is that okay? And 2x times negative 4 is what? Plus ax, right? Is that okay? Yep, low, low. See, I forgot. So that's going to be negative x squared plus ax minus 7 over x squared minus 7 squared. Now, how do I find the horizontal tangent? Horizontal tangent is what? What does the horizontal tangent mean? Make it equal to 0. So 0 is equal to this, right? Then all you gotta do is pay attention to the top. Why? Bottom equal to 0 is actually a vertical asymptote. So it's not a horizontal tangent. Because if you think about it, bottom equal to 0 at square root 7 and negative square root 7, that's going to be a vertical asymptote. It's not a horizontal tangent. So then you say negative x squared plus ax minus 7 equal to 0. Take out negative sign, it's going to be x squared minus ax plus 7 is equal to 0. Factor that, so it's going to be x minus 7 and x minus 1. X equal to 7, x equal to 1. So there we go, this horizontal tangent. Khrushchev's whispers, should I plug in a coordinate? I mean, if you want to, it's fine. But I right now, I just want you to find the x value. Because of burning x value. But if you want to find the point, it's not a problem. And that's easy go to check. So guys, you should check your answer to decimals, not photomath. I hate people checking to photomath.
What?
Photomath is the dumbest thing because it just makes student much weaker in math because they just show you all the work and student perceive that they think they know math when they go do photomath. Exactly, that's good for you. You don't need to know what something called math way in photomath. I mean, it's good for use for certain reason, right? Right now, I want you to get better on foundation, work it out, and ask other people where I did wrong, rather than go to photomath. Because you ask other people ask other people's feedback is better than going to photomath. Other people's feedback might not be correct 100% of the time, but it's gonna help other people to look at the wrong work. So, for example, somebody did this. This is one of the question, 10 of x, and they're supposed to take it to plug in pi over 4. And they say, oh yeah, I remind people says use quotient rule. So I say sine of x over cosine of x. And I see the person take it the wrong way. Why do they do it wrong? They take a derivative. They say cosine of x, negative sine of x. What is wrong with that? What is wrong with this? You can take a derivative top and bottom like this. Because this is present in the quotient, and you have to use quotient rule. Ethan, did you do that?
Yeah, I did.
Okay. So if you take a derivative, it's going to be low d high minus high d low over low low. So that's equal to cosine square of x plus sine square of x over cosine of x squared, right? That's equal to 1 over cosine square of x. That's also equal to secant square of x. Then you can plug in pi over 4. What is secant square of pi over 4? Secant of pi over 4. And some people say, I don't know how to do this. We'll figure out what is secant of pi over 4. What is that? No, it's not 1. 2 over what? Root 2, right? Because square root 2 over 2 is a cosine, right? Then that's equal to 4 over 2. That's equal to 2. So that's equal to 2. Of course, you can plug in pi over 4 into original. So tangent of pi over 4 is equal to 1. So it'll be y minus 1 equal to 2 times x minus pi over 4. And that's your equation tangent line. Good job, Ashton. That also going to lead to today's lesson. We just prove that derivative of tan of x is equal to what? Secant square of x. Good. Now, I want you to also prove that derivative of secant of x using quotient rule. How do I take a derivative of secant of x using quotient rule? Well, if it's a quotient rule, then I have to set it in quotient, right? Does that make sense? So what's the quotient of secant? What is it? 1 over cosine. Say out. Say with like confidence. Like, don't whisper. Cosine of x. Good. That's fine. Don't be shy. I know you a long time, for 2 years. You don't need to be shy. Be brave. So derivative of cosine 1 over cosine of x. So low, right? D high. Not 1 over negative side, no. It's quotient. You have to use quotient rule. Minus high, D low. Over low. Is that okay? So that's equal to sine of x over cosine of x times 1 over cosine of x. Is that okay? Because I split the cosine of x because it cosine of x times cosine of x. Actually, I'll write it in a different order. So that's going to be, this one's going to be secant of x. Is that okay? And this one's tan of x. Got it? So derivative of secant of x is equal to secant of x tan of x. Now, after today, I don't need you to prove anymore. If I say take a derivative of tangent of x, you guys told me is secant square of x. Rather than using definition of derivative, rather than using quotient rule, because you have memorized, because you have all those tools in play. So what are the tools in play? Is right here. This is all the things that you know now. Copy. And I'm going to paste right here. Is that okay? You know how to take a derivative of sine of x equal to cosine of x. Take a derivative of tan of x equal to secant square of x. You can use this now. You don't have to prove it anymore using quotient rule. Because once I prove, it becomes one of your drawback. A lot of people still try to say, I'm not going to use definition of derivative. No. If I didn't say use definition of derivative, don't use definition of derivative. Because of the senseless. You have new tools. Why would you want to use a fax machine when you have a text message? Right? You're learning each new tool. You're learning how the history of tools evolving and then using new tools. Unless I say use definition of derivative, find the derivative of this. Yes, you're going to use definition of derivative. Unless I say use quotient rule to find the derivative of tangent of x, then you got to show me the derivative of tangent of x. Now, this is anytime there's a pattern. So I remember this side. The other side just counterpart. Now, anytime you take a derivative of anything start with a c on the trig function, write it down. Do you see that C is always result what? Negative sign. Anytime you have a derivative of anything start with a C, trig function, it's end up result to be negative. Always. Now the other one just pattern, right? Cosine of x equal to negative sine of x. Cotan is actually the counterpart of secant squared, will be cosecant squared of x. And cosecant of x is going to be cosecant of x, cotan of x. Now, I'm going to help you. I will make an index card here and just memorize everything and always use it. But I'll help you the one on the box. One of my students, Bobby Cena, he failed my class about 10 years ago. Not 10 years, over 5 years ago. The one of major contribution that he did is like he come up with a special way to memorize this, which is pretty funny, I thought, but it's kind of inappropriate, but it's okay. Who gives a shit? I'm live streaming this right now, but it's again, this is not from me. It's not from me. It's from a student. I love the student, by the way. He's so great. He wanted to be a president since he was 8 years old. So every person he ever met, he will come up to you. He will shake your head. He's like, "Hi, my name's Bobby Cena. What's your name?" And the person will say, "Oh, my name's William Lin. Nice to meet you." He's like, I will try to run for president at 2040. Make sure you vote for me at 2040." Every single person he met, and he memorized every single person's name once he met, shake their hand. He has such a good quality. He also have other qualities, kind of sus, but I thought he's great. He still teach my son. I hire him to teach my son English. He's really good at it. So he come out a special way. He failed this class. Every time he would try to cheat my class. The only time he take a test, every time he take a test, he take a big huge ass glasses and he take it out and instead of sitting, he will pick the smartest student to sit next to, and he start gonna ready to cheat out of him. I was like, "Bobby, come on. The only time you use glasses is when you are on a test day." And but he's like, no, I studied for this test. I did well. Oh, I come up with a special way to memorize this. I say, "Okay, what is it?" He's like, "It's really easy." He said, "If you have a 10, that means you get to have sex twice. And if you have a sex, that means you're gonna have sexy 10. So
I'll test my memorization.
let's whatever works, right? Whatever help you memorize. So that's what he come up with, and it was just once you have 10, then you must have sex twice. Well, if you have sex, then that means you have sexy 10. Now he also come up another side of this I can't share with you because that's even more inappropriate. So I'm just gonna leave it like that. Now you want to know. Now
No, I don't.
No one knows.
I don't.
No, don't worry about it. So just remember the counterpart of this, and that's fine. Now here's another question I want to go through is this one. Okay, so make sure that don't say they're from me. They are from a student named Bobby Cena. He's actually a funniest kid. I will tell you a story about him. So if I have this function, hold on, I'm gonna draw it in particular way. So this is an NCL. So I have a graph. Oh, by the way, sorry. Before that, I want to talk about something else. So how much time I have?
4 minutes.
Okay, good. F prime of x, that's the first derivative, right? F double prime of x, that's second derivative. Is that okay? So I can ask you second derivative today. I can ask you third derivative like this. After third derivative, it's going to be a parenthesis like this. That's the notation. Is that okay? The fourth derivative. The fifth derivative after that. So what if I have f of x is equal to sine of x? Can I say, hey, I want a 173 derivative of this. Is there any quick way to do it? What do you think is?
Divide 173 by 4 and use the remainder and then put that through the sine since it will loop every 4.
Hey, whatever.
Sine to cosine, cosine to negative sine to negative cosine to sine.
Okay, I'm gonna write it out for Ian, but Ian's really smart. So if I take a derivative of this, it's gonna be cosine of x. If I take a derivative of cosine of x, it's gonna be negative sine of x. Is that okay? Negative cosine of x and sine of x, right? And if you go to fifth term, it start repeat itself. Do you see that? Every fourth term, it will repeat itself. So it's like a I problem. Remember?
It's cosine x. It's cosine x.
So 173, and that's gonna be fourth. So it'll be 4, 16, 1/3, and 3 is 12. That's 1, right? So remainder is 1, so therefore it's gonna be cosine of x. So cosine of x. Any questions? Yes.
Why do you divide by 4 again?
Because every 4 times it's gonna repeat itself.
Oh, yeah.
Now, what happened with this question? This question is going to be some homework question today. It's going to say f of x times g of x. So I have two graphs. One is f of x and one's g of x. And I will say, hey, take a derivative of this and plug in 1. Okay. So how do I take a derivative of h of x? Well, that's going to be f prime of x, right? Times g of x. Is that okay? Lefty right, righty left, right? It doesn't matter what you order. So I'm going to be f of x times g prime of x. Is that okay? Is that okay? If I want to find out h prime of 1, what will happen? That means f prime of 1. That means g of 1 plus f of 1, g prime of 1. Is that okay so far? So what is f prime of 1?
The experiment can help the slope of 2/3 with.
Do you know why did he come up with 2/3? H
Well,
prime of 1, f prime of 1, that means slope at x equal to 1 for f function. So do you see this is 2 and this is 3? So that's 2 over third. Is that okay? What is g of 1?
G of 1, that would be negative 2.
Negative 1. Good. What is f of 1?
Let's see, I'm
3. And what is g prime of 1?
negative 1/2.
Negative 1/2. Good. And if you simplify this, this is going to be a right answer. So negative 2/3 and minus 3 over 2. And I need a combined fraction. So that is equal to negative 13 over 6. So the answer is negative 13 over 6. So if I ask you g prime of 1, that means find out the slope at x equal to 1 for g of x function.
So one good thing about using an iPad is you can put these in and write on that. Stop. What's the negative? I have two different versions of Google. No, the pencil goes in the iPad case.
What's that?
The most terrifying thing you can say.